Welcome back to the channel, everybody. Today we are going to be 3D printing some extra horsepower on my 2GR swapped MR2, and by we I mean Mark over at Frankenstein Motorworks. This is the intake design that he made over 400 wheel horsepower with. Of course, not just this intake, but with cams and high compression and E85. But anyways, he 3D printed these prototypes and did a basic dyno testing with them, and it survived. Then he continued to produce these in machined aluminum, which looks super nice, but I cannot afford that. So I went over to Mark and went, "Mark, can I pretty please have the prototype?" And Mark said, "Okay." So here they are. They're 3D printed in MJF nylon HPPA12. It has 5mm wall thickness minimum and 8mm where he could fit it, which should be plenty. And at the end of the day, it's plastic, so it would be unlikely to kill the engine if it happens to melt and blow up. I traded Mark my manual door cards and regulators, which in mint condition I guess you could value at around 700-ish. So I got this intake for almost half of his production part, which he no longer makes because he has a lower profile one now. But they have the same rudder length tuned for 8100 RPM. Now my ECU has the rev limit at 7200 RPM, but I intend on upgrading the valve springs and revving to 8200 down the line anyways. So this is just kind of a stopgap. Now for this to work, you will need to purchase a Holley high ram upper plenum. I highly recommend going to Wilhelm Raceworks for this, as he sells one that he modifies to better fit the MR2 engine bay and has a custom flange that bolts straight up to the Tundra throttle body. But I'm cheap. I found mine on OfferUp for $200, painted in an ugly red, but it was cheap, so I just went ahead with that instead. The one I bought was for a 105mm throttle body. Now Mark makes an adapter for the 95mm, but unfortunately it won't fit, so I was stuck making my own. I ended up buying a 3D printer just for this project and ended up designing and printing my own adapter and doing it again and again and again and again and again. I'm using a 5.7 liter Tundra 3UR throttle body that I got off eBay for 35 bucks. It tested fine, but after a while it would throw a P2111 code. So I consulted Facebook. They said the throttle body is bad, so I bought a 4.6 Tundra throttle body. These are functionally identical. It has the same bolt pattern, same 76mm size, and it also threw the same code. So I made an adapter to put the stock 70mm throttle body on the intake. It worked fine. I made an adapter to put the Tundra throttle body on the stock manifold, and it worked fine. Turns out they were just sticking sometimes, so I lightly sanded the carbon with 600 grit, and now they work fine. Also, if anyone with a Tundra throttle body has a high idle, there's a screw hiding under epoxy to adjust it. But finally, after 20 days of off and on diagnosing, I got the setup to work. Also painted the ugly upper plenum black. So first impressions, the sound is incredible. It's hard to pick up over video, but in person it's a lot louder. But dyno impressions, it's slower in the mid-range, but it pulls harder to redline. It's a given when you shorten the runner length, the mid-range suffers, so I came into this knowing that. So how much power did I gain? Well, sorry to disappoint, but I did not take the car back to the dyno. I plan on doing so after valve springs and after revving it, just to make the trip worth it. Instead, I did several second gear pulls with both the stock intake and upgraded intake and logged the mass airflow data. There's a lot more factors that go into horsepower, but this does give a general idea of the curve. As you can see, power is lost from 3 to 5,000. It goes back to normal from 5 to like 6.5, and from there it gains more power. Now how much more power? Well, my original setup dynoed at 285 and flowed a peak of 261 Gs per second. The new intake flowed a peak of 272 Gs per second. Now if we scale the airflow numbers to my dyno and then apply that to the new intake, we would hypothetically be at 297 wheel horsepower, or a gain of 12 horsepower. Now Mark and another dude on Facebook did real dyno testing, and they each showed 20 to 23 horsepower gain on the stock cams. So where did my 8 horsepower go? I believe it's because of my 3-inch intake, because both other setups use Mark's newer 3.5-inch intake. ATS Racing also shows a big gain using their 4-inch intake, so that kind of reaffirms my need to upgrade that. I'm also on the original tune. When upgrading the intake, there's small VVTi tweaks to be made because it changes the intake resonance, so I will get that fixed when I send it back to Mark to raise my limiter. So in my opinion, you have to add a couple more mods to really make this intake worth it. Stay tuned for more.